In this presentation, I'm going to show you different options for local large language model hardware, which we have in 2025. I'm going to show you the implications of these different choices, the rough price structure. Let's have a look at the different hardware models we'll discuss. First of all, there's the upcoming Nvidia DGX Spark, which has been launched earlier this year but is still not available, so there's no actual hands-on data as I'm recording this. But I'm going to give you some predictions based on memory bandwidth. There's of course the Apple Mac Studio M3 512GB, which is already available. Intel's project Battlematrix, which some subscribers have mentioned to me in the YouTube comments here, and I'm always open and interested in your comments. So when you notice some interesting hardware you want me to have a look at, or an interesting large language model, please drop it into the comments below. And also drop which options I'm missing. There are of course bonus slides for several of the options. I didn't want to overcrowd this slide, but if you've watched till the end of the video and there's an important option missing, please do let me know in the comments below. That being said, here are the main options we're going to run through: Nvidia's DGX Spark, Apple Mac Studio M3 512GB, Intel's project Battlematrix, AMD's Ryzen AI Max Plus Pro 395, wow, that's a mouthful, Strix Halo in other words, and that's the code name for this, and Nvidia GPUs of course. And watch out for those bonus slides. Let's start with DGX Spark. It's a $4,000 system, although there will be other options, let's say from ASUS, which will launch a $3,000 option. Also HP and Lenovo, I believe, are partners of Nvidia for this first stage for the Nvidia, and they call their systems differently. Nvidia calls them DGX Spark, ASUS will call it Ascent GX10, for example. And it's already available, and you can sign up for notification when it gets released. I've done a separate video on this. So with the DGX Spark, the main thing to know is that it has unified memory of 128GB, which you can see here. And this high bandwidth unified memory, well, high bandwidth is relative, as we'll see on the next slide, but basically this powers both the CPU cores and the GPU cores on this GB10 superchip. It's got a Blackwell GPU on it, a Blackwell generation GPU, which is the currently newest GPU Nvidia is offering, with 1 petaflop of floating point 4 AI compute. Now this floating point 4 AI compute is it's sparse, so it's not dense, so basically but let me show you on the next slide. And the other interesting thing about this here is it has a ConnectX networking interface, which would allow you to connect two chips or two DGX Spark systems together in one kind of super system, which I will also give you some more details now on the next slide. So let's have a look at this. This slide is quite full, but I wanted to squeeze all the relevant information onto this. Let's go through it step by step. Again, we have the GB10 superchip, Grace Blackwell. We have 128GB of RAM. Now this is, as far as I know, always the same configuration, so always going to have 128GB of RAM. For the $3,000 systems, you're just going to have 1 terabyte of SSD storage instead of 4 terabyte. My recommendation here would be to consider going for more storage, as these models fill your hard drive up pretty fast, typically. It has 273GB per second of memory bandwidth. Now there's two things we can do. We can calculate a theoretical speed limit. So this is the absolute maximum speed limit at which this should be able to work. Keep in mind, realistically, the real life speed will be lower for the Llama model, for example. Here we have the KV cache, which we need to add. There's some inefficiencies and other things. So basically for Nvidia, from previous research, which I've done on the internet about reported numbers, I've noted that if we take the theoretical speed limit and multiply it by 0.8, maybe 0.85 in exceptional cases, we reach a good real-life value which can actually be achieved. So on the Llama 3.3 70 billion model with quant 8 quantization, which roughly has a 75 gigabytes model size, we come in at 3.6 tokens per second at the theoretical speed limit, and for real life we would expect about 3 tokens per second. I already mentioned the different SSD configurations, and to my knowledge Nvidia itself only offers the 4 terabyte configuration. It has 1000 TOPS or 1 beta ops, but it's floating point 4 in sparse. So if we divide that by 4, we get to 250 int 8 TOPS, which is better. Note TOPS is actually tera operations per second, while floating point you would expect flops, so that's a bit of a question mark for me here myself, but let's just roll with it. So that's roughly 250 TOPS for int 8. As I mentioned, 2 machines can be linked together using the Connect X7 Smart NIC at 400 gigabits per second. This is really fast. In fact, from my understanding, it should actually be faster than the SSD or typical SSDs which you have in your hardware. So it will basically, it will not reach the actual memory bandwidth, but you can really push things faster from the other system's memory than from the SSD which you have in your system. My understanding is that 2 of these can be connected. It's still a question whether more than 2 would be able to be connected. What type of hardware you would need? Probably there are some switches which you would be able to use. Of course, if you are able to use these switches, whether that would be cost efficient, etc. But for now, let's just assume that you can connect just 2 systems. As more details get released, I will for sure make additional videos on this. By the way, if you have any other questions about DGX Spark or are wondering about different aspects of it, please drop this into the comments. I can't promise to deliver videos immediately, but I do want to mention that I am, with my company, an ASUS partner, and that is why I will probably be able to get some insights, or at least ask the right questions, and your comments will really help me to ask the right questions and also understand how much of a risk I should take concerning the DGX Spark or the ASUS Ascent GX10 for my business. So your support would mean a lot for me in that. Now, getting back to our presentation here, the Llama 3.1405 billion model at 4-bit quantization, please note this is 4-bit, this is not 8-bit as above, will be weigh in at roughly 217 gigabytes, and we will be able to fit that across 2 of these devices. A theoretical speed limit I've come up with for this would be 2.5 tokens per second, and in real life I would estimate it to drop as low as 2 tokens per second, because obviously you have also some additional networking overhead, and the link is not as fast as if it would access memory directly. You have some additional overhead in splitting the model and synchronizing across 2 different machines. But I think 2 tokens per second should be reachable, and I'm really looking forward to get my hands on these devices and test it myself and be able to report real numbers and or get feedback from the community of someone who's tested it. Next up, we have the Apple Mac Studio M3 Ultra, which is a very strong contender, and I am really enthusiastic about what Apple is doing in the market. They have strong memory bandwidths, they have very solid pricing, and they have huge amount of memories in this. So if you consider getting one of these machines, I think you probably will not be disappointed if your primary goal, of course, is inference and not training. For training, that's a different beast. This video covers inference really. training is probably where you would want to stick with Nvidia mostly, I guess, specifically because of the whole tool chain and other things. Possibly AMD might be an option as well, but I would not recommend to look down the Apple route for training just as of now. So the Apple Mac Studio 512 gigabytes. It has the Apple M3 Ultra SoC. It will come in 96, 256 and 512 gigabytes of RAM, which drives the price along with your choice of solid-state disk, which can be between 1 terabyte to 16 terabyte. Again, also a very broad range, allowing you to do lots and lots of things with it. It has a fantastic memory bandwidth of 819 gigabytes per second. Now, one thing I should mention is that typically the token generation is constrained by the memory bandwidth. So actually the GPU cores are sitting idle or waiting for more weights to be pushed into them. Now on the Mac we might get to a point where actually the cores are working at full speed and the memory bandwidth is not fully saturated. That is a possible reason why, and what I've seen is basically for the theoretical speed limits on Macs, they are higher than the actual output. This might also be due to software optimizations, but my guess is that it's actually a mix of both of these things. So that's something you do need to factor in. And that's why I'm giving here this real-life Llama 3.3 70 billion parameters quant 8, 6.22 tokens per second in real life, compared to a 10.9 tokens per second. As you see, it's roughly 62%, something like that, 65 maybe. So basically you are not looking at 80%, but 60-ish. Then the Llama 3.1405 billion parameter model will fit, and it will fit in 8-bit quantization, which is roughly 434 gigabytes. It will barely fit. You will need to take into account how big your KV cache is, how big your context window is, etc. But the theoretical speed limit, if we calculate it for the 8-bit quant, would be 1.8 tokens per second. Extrapolating using the roughly 60% utilization of this for real-life tokens per second, we get to 1 token per second. Now, if you actually want to know and understand how would this compare to the DGX Spark, which we used 4-bit quantization for, because of 8-bit quant would not fit across the two systems, you just multiply the number by 2, because you get roughly half the size of the model. Give and take, there's like things, but basically in real life, if we would use 4-bit quantization, we would get to 2 tokens per second here. Apple does not publish the TOPS. In this case, we do know that the neural processing unit is 36 TOPS, but what we're really interested in is the TOPS performance on the GPU cores. There's no information on that. If someone of you has information or a valid source, again, please drop into the comments below so I can use that for other videos going forward. Then we do have very interesting networking options on the Apple Mac Studio, which would allow you to also create clusters of these machines. We have 6 Thunderbolt 5 interfaces for a total of 720 gigabytes per second. And also we have 10 gigabyte per second Ethernet. So this is a very, very solid machine, which you can run a lot of LLM inference on. Again, for LLM training, another machine might be a better choice. Moving on to Intel Project Battlematrix. Intel Project Battlematrix is an interesting one. It's Intel's response to the growing Nvidia popularity, of course. And what they do is they offer you these GPUs Intel Arc GPUs, and they offer configurations along with partners, where they sell these GPUs along with a host system. And it's it's not like the previous two, which are integrated systems, but it's more like Nvidia RTX GPUs, and specifically more so the professional grade, I would say A6000 and so on, which you can cluster in your device. So each of these GPUs, and that's where the comparison goes bad, but each of these GPUs comes in at $500, and a system might be between $5,000 to $10,000 depending on what you're looking at. So here we have an overview. We're talking about the Intel Arc Pro B60 GPU in particular with 24 gigabytes of RAM. It has a 456 gigabytes per second of memory bandwidth. Again, I retract my earlier comment about comparing this to the A6000. Actually, the A6000 has much higher bandwidths, 1792. We will get to it later in this presentation. The 456 gigabytes memory bandwidth, gigabyte per second, will allow you to do about 6 tokens per second, theoretically, on Llama 3.370 billion quant 8. Now, please note, the Llama, as it's roughly 75 gigabytes, will not fit on a single Intel Arc Pro B60 GPU, so it needs multiple GPUs. And I will have a summary later on where we'll estimate some actual values for what it might be in real life. But basically, please keep in mind these needs multiple GPUs, and this is a bit more challenging to pull off. So if you're looking for an easy option to run this Llama model, probably, and you want to run it locally, probably a Mac or the DGX Spark, ASUS Ascent GX10, might be an easier approach. You don't need to work through clustering and stuff like that. We do know the tops. So we have 197 tops, int 8 dense. And for comparison, this would roughly equate to 788 int 4 sparse tops. So as we see, this Intel Arc Pro B60 GPU is less powerful than the DGX Spark, actually. If you remember, that has 1000 int 4 sparse tops. The Intel Battlematrix concept allows you to link up to 8 GPUs, which will then add to a total of 192 gigabytes, which will be more than the Nvidia DGX, for example, less than the Mac, of course, but it will have significantly more bandwidth than both the DGX Spark and the Mac. Because if you run the bandwidth across several GPUs and you're able to link them and offload the models and parts of the models, shards of the models across each of these GPUs, or you are able to run multiple requests simultaneously. In any case, if you calculate 8 GPUs for this 456 gigabytes per second times 8, you will get about 3.6 terabytes per second of total bandwidth. And for Llama 3.370 billion at quant 8, that will equate to 48 tokens per second or 35 tokens per second in real life. And this, by the way, if you would actually have a system of 8 GPUs, is at the top end, of course, of the price, which I showed you on the slide before. I can go back, $10,000. Good deal for $10,000. It will support PCI Express Gen 5. So just to give you a comparison or a feeling, Gen 5 with 8 lanes will do 252 gigabits per second compared to 456 gigabytes per second of memory bandwidth on a single GPU. So this is actually an order of magnitude. This will not be able to fit Llama 3.1 405 billion at 4-bit quant. That is 217 gigabytes roughly, and for that you would either need 2 DGX Spark systems or a Mac. So moving on to the Ryzen AI Max plus Pro 395 Strix Halo, which will come in between roughly $2,400 to $3,100 plus taxes and so on, of course. So this system was designed primarily for portable systems or for desktop systems, and it's an SoC specifically with the memory bandwidth being accessible from both the GPU and the CPU cores, called unified bandwidth. So a limit to it, it has a maximum of 128 gigabytes of RAM, and it has a 256 gigabytes per second memory bandwidth. So if we calculate again with Llama 3.3, 70 billion quant 8, we will get 3.4 tokens per second. In real life, I expect it to perform at more roughly like 2.5 tokens per second. As a rough guide, roughly 3 tokens per second are necessary in order to be able to generate at human speech speed. And if you want to run agentic AI, etc., of course, you would need to have a multiple of that in order to be able to run those agents fast enough. 76 TOPS on the GPU in int 8, roughly equating to 304 int 4 spars. Now keep in mind, it's better to compare the Strix Halo to the Mac actually, and not so much to the, for example, the Intel Battlematrix project, because this is a complete chip and it includes everything in this chip, the CPU, the GPU, etc. So it's more like the Mac offering. It cannot fit the big Llama in it, because again we have 128 gigabytes of RAM at most. They also call it the world's most powerful AI PC for enterprise. Do you agree with this? Drop a comment below. Here we come to the first bonus. Talking of Apple, Apple has a MacBook Pro M4 Max, which has $3,199 to $7,199 as a price point. It will run on Apple M4 Max. Of course, I know there's different models and there's even cheaper price points, but for this video, I'm considering the most powerful CPUs Apple has, and the Apple M4 Max is certainly one of the more powerful ones. It has a maximum of 128 gigabytes of RAM, again unified memory, and a memory bandwidth of 546 gigabytes per second, actually being much higher than the DGX Spark memory bandwidth, for example. So the Llama 3.3 will run at 7.2 tokens per second, in real life possibly at 4.8 tokens per second, if we consider the 60% value I've seen from the data on the net. We do not know the TOPS, and of course it will not be able to fit the big Llama, as it's just too big for the RAM. If you really need to run the big Llama on a Mac, go for the Mac Studio. Now we're getting into territory which most people should be quite familiar with. These are the RTX 5090s, 4090s, 3090s of Nvidia and A6000. These GPUs come in at roughly $1,600 to $9,000. And of course you need a system to host the GPU, so you would need to add roughly $1,000 to $3,000 on top of this. At the end of this video, stay on until the very end, because there's going to be a summary and an overview, 2 overview slides, which beautifully sum up the different price points, the tokens per second, memory bandwidth, everything you need to know. Let's have a look at how the Nvidia GPUs stack up, and I'll give you a couple of pointers on them as well. So Nvidia has a more consumer-facing lineup. These are the RTX 5090s, 4090s, and 3090s. The higher the first number, 5, 4, or 3, the more modern the generations. For example, the 5 is the Blackwell architecture, the 4 is the previous Ada Lovelace architecture, which was released in 2022, and the RTX 3090 is Ampere, which is the second generation RTX architecture, and it was released in 2020. Now, from the price point, as you see, the RTX Pro 6000, which is aimed at professional enterprises, architects, and such people who need to render professionally on their GPU or do machine learning and so on, like in a more like at scale, let's say, you will pay more, with the advantage that you have significantly more RAM as option on the GPU. For example, in the case of a RTX Pro 6000, which is based on a Blackwell architecture, same as the RTX 5090, you will have a max RAM of 96 gigabytes, whereas the RTX 5090 is tops out at 32 gigabytes. If you roughly calculate the price and look at the gigabyte comparison US dollar per gigabyte, so you divide the 9000 by 96, the interesting thing is actually the RTX Pro 6000, RTX 5090 are at the exactly same level, $93.75 per gigabyte. Whereas the RTX 4090 is at $95.83 and the RTX 3090 at $66.67 dollars per gigabyte. Now, my recommendation is forget about the RTX 4090. I feel it's kind of the worst trade-off you can make, right? Like it's the more expensive per gigabyte than both the RTX 3090 and the RTX 5090. So either go high-end, really high-end for the RTX Pro 6000 if you can afford it with $9,000 and maybe $12,000 for a full system, or go for the RTX 5090 with 32 gigabytes of RAM. These LLMs are getting bigger and bigger, or you want to do more and more agentic stuff, mixture of experts models, things like that, right? But if you want to go cheap, then go to the older generation RTX 3090s, which will allow you to have 24 gigabytes of RAM, same as the top of RTX 4090, but you will get a small performance hit on the memory bandwidth, but it's smallish compared to the price difference which you get between the RTX 3090 and 4090, right? So that's my recommendation. If you want to save, go to RTX 3090. Do not pick the middle option. The Llama 3.3 70 billion Quant 8 will only fit on the RTX Pro 6000, and that's why I've given 23.8 tokens per second as max theoretical on the RTX Pro 6000 in bold here, and it's italic on the others because these are calculated theoretical values. Of course, since I calculate this using the memory bandwidth, it's the same on the RTX Pro 6000, RTX 5090, same memory bandwidth, 1792 gigabytes per second. And as you see, there's not too much of a big of a difference between RTX 4090 and RTX 3090. And the Llama 3.1405 billion Quant 4 does not fit into a single of these GPUs. You will need to cluster them. Here's our second bonus, the Nvidia DGX Station. You didn't think I would miss out on that one, would you? So let's have a look. I estimate, now this is not a public number, but this is an educated guess, that the Nvidia DGX Station will be somewhere between $75,000 to $150,000. I wish it was cheaper, because it's got really nice specs. So it has the Blackwell Ultra GPU with a maximum of 288 gigabytes of high bandwidth memory, HBM3E GPU RAM with 8,000 gigabytes per second throughput. These are the types of values you want and you lust after, really, if you want to run LLMs fast. And it has a maximum of 496 gigabytes per second LPDDR5X CPU RAM, which has 396 gigabytes per second of bandwidth. And the idea is there's an interconnect which will connect the CPU cores and the GPU cores and allow them to share the memory. So for all intents and purposes, if you want to run even bigger models than would fit in 288 gigabytes of RAM, you can actually link in the CPU or controlled RAM but then you will be constrained by the top speed of 396 gigabytes per second, which is not too bad, compared to the other embedded systems which we have looked at. The theoretical speed limit for Llama 3.370 billion will be at 106.6 tokens per second. In real life, we expect to reach about 85 tokens per second, which blows everything else out of the water. We're not aware of the tops which it will have. At least I'm not aware. If you are aware, please drop that into the comments. And it can, of course, fit the big Llama. It will have a theoretical speed limit of 36.8 tokens per second, and in real life, roughly maybe 29 tokens per second. Now we're talking, right? This is the kind of speed which will allow you to iterate very fast. This is computer meant for professional developers, for people who are actually working for enterprises with these large language models. So this is probably even going to be, I hope that this will go the same way as we've seen it in every hardware since the mainframes, that prices will come down ultimately, and that, let's say 3 years from now, this will not be a $150,000 system, but maybe a $3,000, $4,000, $5,000 system. Let's see. One thing I do want to point out is that the Llama 3.145 billion 8-bit quant will also fit, but it will not fit entirely into the GPU RAM. You will need to pull in some of the CPU RAM from it, which will of course seriously degrade the speed performance, this token per second speed limit. Probably a better way to go about this would be to link up several DGX stations, and yes, they have ConnectX as well, but they have ConnectX in a more updated variant. Just briefly pulling this in, so we have ConnectX 8 on the DGX Station, ConnectX 7 on the DGX Spark, and this ConnectX 8 is capable of 800 gigabits per second. The thing is, they're talking about that it's for AI factories and so on. So this is really data center type stuff, which you would have on your desktop. I mean, they say DGX Spark is as well, but it's kind of more in the ballpark of a Mac, right? Like, so I wouldn't say it's data center stuff specifically with the DGX Spark, but with the DGX Station, yes, definitely you're getting data center type performance on your desktop. And you are able to link several of these together. Yeah, I'm enthusiastic about that. Let's see what the actual price point will be. And now we get to our third bonus, which is kind of like the polar opposite of the system we just saw now. It's the Jetson AJAX Orin. Now, Orin, or the Jetson series, they have several lower performing devices, but this is the high-end device, Jetson AJAX Orin. It comes in at a price point of roughly $2,100 with 1 ampere GPU. So remember, this is kind of like a previous generation GPU, not the newest Blackwell cores. And it has 64 gigabytes of LPDDR5 RAM, or a total memory bandwidth of 204.8 gigabytes per second. Llama 3.3 will not fit. Theoretically, if it would fit, it would be at roughly 2.7 token per second for the theoretical speed limit. OOM means out of memory. 275 tops at int 8. And of course, since even the smaller Llama will not fit, the big Llama will not fit as well. But hey, this is a device which is typically deployed in vision applications on the edge, but also some smaller LLM applications. I know a startup, for example, which are building or using this as one of the first hardware platforms. So in any case, that's the third bonus. And now we have the fourth bonus, which is the AMD Radeon Pro W7900. Roughly per GPU, you would come in at $3,200. So this is the high-end comparison compared to the RTX 6000. And it has 48 gigabytes of GDDR6 RAM at 864 gigabytes per second of throughput. Llama 3.3 will, at 70 billion weight or size, will come in with 11.5 tokens per second. Please note it will need multiple GPUs. We do not know the tops on this, and it will not be able to fit the big Llama, at least not on one model, one card of this. Here's another bonus for you. Now this bonus is a bit different. This is about more information. If you want to get these slides and the comparison which is coming up just after this slide, subscribe to my newsletter on get.businessbreeze.de/local. Subscribe to the newsletter, download these slides, and get fresh information about large language models and other interesting AI topics and developments into your email inbox every week. Here's the promised overview for the local LLM options in 2025. This is the first slide, and I'll have an Nvidia slide coming up next. Now, as you can see, I've sorted this alphabetically: AMD, Apple, Intel, Nvidia. AMD in my video has two offerings, the Strix Halo and the Radeon Pro W7900. I have included the price point for you. I've included the RAM, the memory bandwidth, and the performance on Llama, or not applicable if the big Llama will not be able to load. As we see, if you're actually heading for the most memory on this slide, the Mac beats everything easily and hands down. It also has a really high memory bandwidth, and also, since it has this high memory bandwidth, it translates to a high amount of tokens per second. In this slide, I'm using 4-bit Llama 3.145B. That's why we have 2 tokens per second, roughly estimated. Also, please note these numbers which I'm using here are real-life estimations. So these should be actual values you should be able to get out of these systems. If you do get lower or higher values, please comment below so that I can learn from this. But these are my estimates, what I think this system should be able to do, and actual values which I've seen on the internet, other users report. The Battlematrix comes in at roughly 4 tokens per second for the Llama if it's distributed. The big advantage of it is that it can do this really huge 3648 gigabytes per second. Same as if you cluster the Radeon Pro W7900 and so on. But since this is 24 gigabytes of RAM, you would get 456 gigabytes per second on a single GPU, and here with 48 gigabytes of RAM you get 864 gigabytes of second. So roughly you can probably estimate that they're using similar controllers but just more memory chips here on the Radeon Pro. And in this case you would then put in less of these cards, and they're also of course much more expensive, and in that case you would put in more of these cards. Again, keep in mind these cards here are roughly a $500 each, whereas here I'm giving the system pricing. So this is a full-on system which you can estimate how much it would cost you probably, since then you're not comparing apples to oranges but apples to apples actually. You get the drift. So the verdict from this slide is, if you want to get a machine with a lot of RAM, really easy to use, to set up, quiet and so on, consider the Mac. If you want to get a cheap system but are prepared to do more hand-holding, tuning, and possibly, like even a bit more challenges, you might look into the project Battlematrix or building something with Radeon Pro W7900. And if you need something on the go and you want really solid throughput, consider the MacBook Pro M4. And if you want to be low-end, low-cost, the Ryzen AI Max Plus Pro with a $2,400 price point might actually also get you to 2.5 tokens per second on Llama's 3.370 billion. Right, let's have a look at Nvidia. Nvidia has a really broad range, and I've sorted this slide from cheapest system to most expensive system, from the bottom to the top. The DGX Station has also the most amount of RAM in a single system, 784 gigabytes, but it's also probably much more expensive than the others. We have 8,000 gigabytes per second of memory bandwidth on the HBM3E memory, and the RAM 396 gigabytes per second. As I said, due to the interconnect between the CPU and the GPU, we should be able to use this at nearly the full 396 gigabytes per second. So this will add an additional 496 gigabytes of RAM into our system. Possibly this is useful for mixture of experts systems, really huge mixture of expert systems. For example, the Llama 4 series, it is a mixture of experts system, devised Scout, Maverick and Behemoth. And they have different amounts of these experts in Scout versus Maverick. Maverick, I think, has much more. And I've done a separate video on the Llama 4 series, which goes in depth on this architecture. Basically, here you have 128 experts in Maverick and 16 experts in Scout. Now, this would be a very interesting possibility to run Maverick actually on the DGX Station. RTX Pro 6000 is a very solid choice with a lot of RAM, especially if you intend to cluster it. And it will come in easily at roughly 19 tokens per second with this 1792 gigabytes per second of bandwidth. GeForce RTX 5090 is the consumer's choice if they want to run, and sometimes also smaller companies, businesses will use it to run large language models. Again, you would need to cluster several of these. Concerning my calculation previously that the RAM of the 32 gigabyte and 96 gigabyte version is actually, you pay the same dollar amount per RAM, then you might as well just go for the big one if you need 3 of the small ones, and you will save yourself some integration overhead and so on. The DGX Spark clocks in squarely in the middle of these systems as per my table. Of course, the $150,000 or $75,000 price tag of a DGX Station is really out there compared to the other systems. But the Spark is a good system to look at if you want to run everything in a very small, compact form factor on the Nvidia ecosystem. That's the important point, because there's a lot of things which are in the Nvidia ecosystem. It's already quite developed, software, all the CUDA acceleration libraries and so on, like QVS, CUDA vector search. So if you do not want to invest a lot of time into developing and actually adjusting, fiddling with drivers and stuff like that, which you might need to do for some other brands, or you want to do fine-tuning, you want to do model training, or at least a smaller version of it, the DGX Spark might be an interesting application. And looking beyond large language models, there's also things like protein folding and adjustments and sequence predictions and other medical or pharmaceutical applications, which I think are quite interesting. Generally, I think the Spark is probably a good choice also for offline computation. If you are not doing things like hard real-time chat with users, but you're analyzing emails and so on. So that's an area I want to explore more in this video. If you, not in this video, but in future videos, if you have suggestions concerning this or ideas or questions, please drop them in the chat below or book a consultation session, which I'm going to come to in a minute. The GeForce RTX 4090, as I said, I'm not a big fan because, you know, price-wise, the 390 is just a little bit lower performance, but price-wise just much lower compared to it. And the Jetson AGX Orin, again, is a more like all-in-one system, which is really compact on the edge. I guess if it's fast enough for you, then it might be a good choice. Probably if I was to choose a system today, and I had enough budget to run large language models, I would probably opt towards the Mac, to be honest. Since this is, I think, the Mac Studio M3 512 gigabytes, this is the kind of easiest option, which will give me a huge amount of memory and run these things. The DGX Spark is something I want to explore more specifically with the Nvidia ecosystem, what can be done and how fast it's to build on this compared to the Mac. And otherwise, I think if I was building systems, and again I had the cash, I would go towards the clusters of RTX Pro 6000, simply because it has a really nice memory bandwidth. It's 1792 gigabytes per second compared to AMD's 864 gigabyte per second, and again, you know, more RAM per device. And also it has, I don't tire of repeating it, but it has Nvidia's ecosystem. And when you're running a business, what you don't want to do is you don't want to invest a lot of time into enabling your hardware. You want solutions which just work. Which brings us to the last point, which I want to mention here. If you have further questions about large language models, you want to discuss things further, you need answers, you need solutions, you need an idea or maybe even training for your CEO, C-level executive suite about what this whole large language model hype is about, how you can participate, what needs to be done for your company, what type of hardware you need to run, if you need to run locally and so on, please reach out to us at get.businessbreeze.de/consulting. We do offer a limited amount of free 30-minute strategy calls, and I'll be happy to discuss your team and your team's needs on one of these free strategy calls. We aim to deliver value. Your satisfaction is our priority. Again, if you need or if you're in the market for consulting concerning large language models and solutions, get on our link, get.businessbreeze.de/consulting, and book a free session there, if there's still limited spots left. What do you say about this video? Is this type of information what you want more of? Comment below, give me a thumbs up, and thank you so much for watching. Have a fantastic day, and let me know what systems you prefer. Take care, bye.